All right, example number 2. Okay, here we see a similar problem, except for they put LB on the end, which you might recognize that stands for pounds. Okay, now, unlike number 1, this is actually a real life example. Okay, what this would mean is that a force of 4 pounds acting at 50 degrees is acting on a force of 170 degrees, okay, of -6, okay, which is going to mean in the opposite direction. Okay, and what we're going to find is what is the resolving force. So now we're getting more into the physics, into the real application of this. Alright, we're going to do it the same way though. It doesn't change. Alright, so I'm going to just briefly show this setup, and then you would do it the same way that we did before. Okay, you have this 4, okay, 50 degrees would mean that it would be in this quadrant. So we label 4. Alright, 50 degrees. We're going to solve the same thing for J and I. Alright, so then we would again have sine of 50 degrees is equal to J over 4. And the cosine of 50 degrees is equal to I over 4. Okay, here, now this is a little bit different. Alright, 170 degrees. Alright, that would put us in this quadrant. Okay, 170, that means we'd need 10 degrees left over to get to 180. Alright, now, I'm going to stop right there. -6 is actually telling me that it's the opposite force. Okay, the force acting against this. Alright, so we're actually going to draw, it's talking about this vector down here. So it actually would be going this way. Alright, so my angle inside is 10 degrees. The hypotenuse 6. Label this again I and J, or like X and Y. Set up my equations again. And we have sine of 10 degrees is equal to J over 6. And then the cosine of 10 degrees would be equal to I over 6. Alright, I'm going to stop right there because we're actually going to solve this the exact same way as we did the other one. Remember, these would be both positive because we're going to the right. I'm going to the right myself here. Okay, this one I'm going to the right, but the J is actually negative. So we want to make sure, because that force is acting against a force going up, that we make that negative.